all, welcome everybody. So just to get started, who am I? I'm a security researcher from Montreal. I'm currently working at Desjardins, and we have a group named AppSec. This is usually the name under which we do most of our publication related to security. I also help organize a bunch of events in Montreal and Quebec City. So usually, if you come to Montreal to some event related to security, there's a good chance you're going to see me there. So just to get started, so today I'm going to first go as to why I wanted to build this plugin, how it was built. There's going to be a very, very short demo, and some of the future improvement to what has been done. So just to give a bit of background, last year I published a piece of research that was called Prototype Pollution Attack. And I wanted to continue this research on a bit larger scale. And what I realized very quickly is that continuing this type of research on a more larger scale required me to have some static analysis or dynamic analysis tool, because it's otherwise a huge pain in the ass to review a lot of code. So I started to look at what was existing, and I found there was barely anything that could be used for this type of thing. So one of the main reasons I started to make this static analysis engine was just to continue my own research. And the second reason is that the existing tool to do endpoint identification are, for most part, only using regular expression, which has some kind of significant limitation. So how it was built. When I started to build this plugin, I asked myself if I was to look at a piece of code, how I would identify endpoints in that piece of code. So let's say that we have a very, very simple piece of JavaScript code. How do we identify endpoints? Well, the first thing that we would look for is, first of all, identify where are the AJAX calls. So in this case, we would see that there is an API for the jQuery API, that's $.get. And we would see that this is where we can have a potential URL that's passed. However, we see that there are some that the URL is dynamic, which means we don't know exactly what its value yet. So what we do is we look at the variable that are used to build this URL, and we find where they are coming from. So we can see that some parts are a static value, some other parts are arguments that come from the function. And after that, we would look to identify what are the possible value of foo, and we would look at where ABC is invoked and to find the possible first argument of this function. And at a very, very high level, this is how the plugin and the engine behind the tool works. So this is a very, very brief explanation, and it might look easy, but in practice, not exactly trivial to build this sort of engine. So what do we need to build this? Well, we're going to first of all need some way to make some symbolic representation of the abstract syntax tree. And we're also going to need some sort of call graph representation that we're going to be able to navigate to resolve function arguments. And just for those that are not necessarily familiar with static analysis, I'm going to refer to AST in the slides as abstract syntax tree. This is basically sort of an object representation of the code. So instead of dealing with a massive string, we're just going to deal with an object representation that represents each token of the syntax of the language. This is usually a representation that's very commonly used for static analysis. Yep. So first of all, I'm going to talk a bit about what does it mean to do some symbolic representation. Symbolic representation is basically just meaning instead of dealing with actual value, we're going to actually represent variable as symbol. So if we don't know exactly, for example, in this case, the value that base and foo holds, we're simply going to represent the value of target as a concatenation of two variables. And eventually, if we can concretize the value and replace those values afterwards, we're going to use this symbolic representation. Also, as we analyze code, when we're dealing with symbolic value, we can also do some replacement. So let's say that we have a piece of code where we have the two following statements, where we have two assignments. In the second assignment, when we're going to make the symbolic representation of it, as we already know the symbolic value of ABC, we can already substitute it with its volume. Yeah. Yeah. So there's a few things I wanted to touch in this presentation, is especially topics that are very, very, very specific to doing static analysis in JavaScript code. And one of the very important things about doing static analysis in JavaScript is mostly to correctly identify which variable maps to what. Because whenever you're dealing with code or minified code, it's going to be very common that there's going to be variables which are going to have the same name, but are not going to be the actual same variable. So if we're doing some symbolic analysis, and we just point to, let's say, and we just say this is a symbol for the variable A in some places, we can get a very confusing results if we're treating all the variable A as this exact same thing. So we need to correctly identify which variable is which. So there's a few rules that need to be taken into consideration in JavaScript. The first one is that variable and functions are hoisted. And what this means is that variable, no matter where they are declared inside a scope, are always considered to be declared at the beginning. So let's say that we take a look at this sort of funky code, and we're trying to identify what is going to be the value of A when ABC is going to be invoked. We might think that it's 1, 2, 3 or 2, 3, 4, but it's actually going to be neither, because if we follow the rules of hoisting, we're going to actually realize that the equivalent that what's actually happening is the following thing, is that the variable A is considered to be declared at the beginning, and so the value is going to be undefined. So what this means when doing static analysis of JavaScript code is that whenever we're entering a scope, we must always do some sort of pre-analysis that's going to gather all the variable and let declaration before doing any analysis, because otherwise we can have cases like the function that I showed here, where we're doing some incorrect analysis as to where the variable comes from. The other thing to be aware of is all the variables are resolved in the JavaScript language. Let's say that we are trying to identify which variable the foo and val value represents, let's say that we're trying to identify what foo and val variable are actually mapping to. For the val variable, so just gonna take a break. So basically the rules, the way they say is that we first of all have to look in the current scope. So for the val variable, we can see that there is a var declaration for the same name in the current scope. So we know that the val variable maps to the var to the variable that was defined in this scope. However, if we look for the foo variable, we can find a var declaration for the foo variable. So we have to look in the parent scope. So in this case, and since we find it in this scope, we know that it's the foo variable from the parent scope that it actually maps to. And if we couldn't find it there, it would be considered global or the parent scope. So the way the engine deals with this is that, first of all, the symbols that we're using for variable are not directly the variable name. Whenever we encounter a new variable, we're assigning them and giving them some sort of unique identifier. And this really helps to correctly distinguish between variables which have the same name but are not the actually same variable. So when we're entering when we're starting to analyze, let's say, the function ABC, we will build a map that says for the variable foo, it actually maps to a symbol which has the name global ABC foo, and for the val variable, it's actually mapping to a symbol that's global ABC val. And when we're entering a child scope that's inside the scope of the function ABC, we first of all make a copy of the parent scope, the mapping of the parent scope, and we override a new value that exists in the child scope. So we would see that the val maps to a symbol that's inside of the child scope, but that the foo still maps to the same variable that was in the parent scope. So in this way, we're correctly mapping to the correct variable. Yeah, and we also need to build a call graph. So every time we're doing this analysis and we encounter a new function call, we're basically storing information about this function call. And we're basically keeping as a key the name of the function or the symbol that's called. And also, as we already have a symbolic representation of the arguments at this point, we're also storing the symbolic representation of the argument at that point. Yeah. So basically what this sort of call graph allows us is that whenever we're going to try to resolve a variable and try to find, let's say, what can the value of the first argument of the function ghi can be, the way we're going to parse this is that we're going to see that the first argument can actually be a variable that's a function argument from the function def. We would look at where the def is invoked. We're going to see that in one of the invocation, it's a variable that's a function argument of the function abc, and we do the same thing until we find that the value can be a constant, which is /API. So that's roughly how the call graph is navigated. So now that we have all this information about both the call graph and some sort of symbolic representation of the code, how do we identify AJAX call into this? Well, the way the engine works is that it looks at all the function call that it gathered during this analysis, and it looks for very, very, very specific signature of function that are called. So it looks, for example, a global object that's named $.get, and an object that's of type XML HTTP request.open. So it's very, very precise thing. It's not just something.get, something.open. It's very, very precise thing that we're looking for. And this is to kind of help with to avoid false positive. So once we identify that the function is actually an AJAX call, we're also doing the same analysis to resolve the function arguments, which are kind of the only arguments that can still be resolved in the symbolic representation. And this gives us a list of possible value that the endpoint can call. Yeah, there's a few things about resolving arguments that are still noteworthy to mention. It's mostly like two cases that need to be taken into consideration. The first one is when we're trying to resolve argument, it's very important that we resolve them all at the same time. Because one of the naive way to implement a variable resolution is to say, in this case, we're trying to identify what are the possible value of foo. It would give us that there's two values, which are 5 and 3, and we're going to separately identify the possible value of bar, which would give us 2 and 4. However, if we're doing like a cross match of those, it would tell us that there are 4 possible values for the URL, which is false because, as we can see in the code, there's only 2 invocations of the function abc. So when we're resolving the variable at the same time, it would correctly give us that the only 2 possible values are 5.2 and 3.4. The other thing that's sometimes happen is that sometimes the variable that are function arguments come from different functions. So we sort of have to prioritize which function arguments we have to resolve first. And the rule that I found to work the best and causes the least issue is to always start with the one that's like the deepest. So in this case, we would start by analyzing bar, and then we would resolve foo as it afterwards. Yeah, so I'm going quite fast, which is good because I'm going to have time for other thing. Yeah, so one thing that's really interesting is that at this point, we're always able to kind of reconstruct the information about the URL. So we can already gather the static part of it, and we can already tell that some parts are going to be dynamic. And yeah, this is already useful information because we're going to know which parts are dynamic, which means this is usually the parts we're going to want to fuzz. However, what's really interesting to also provide is to also be able to tell that the dynamic value where this comes from in the code. So the way the engine does this is that whenever we're transforming values from the AST to their symbolic value, we're also keeping all the information that the AST has in regards to the code location into the symbol. So whenever we're trying to resolve the value and we can find a concrete value for the symbol, we still have information about where it came from in the code. So we're passing that information along. Yeah, and in that way, not only can we provide information about the URL and what's the variable part, but we can also tell what those variable parts can come from. Yeah, and one last thing before we jump to a very, very short demo is that there is some partial AngularJS support in the engine, and AngularJS is like a huge pain in the ass to deal with static analysis. And this is mostly because it heavily uses dependency injection. And dependency injection is something that's statically, that to analyze entirely statically is almost nearly impossible. Yeah, so the way the engine kind of supports a little bit AngularJS is a bit by cheating, is that the dependency injection, at least the way it works in Angular, is kind of easy to fingerprint. So basically what we're doing is whenever we're encountering signature that we know are the dependency injection signature for Angular, we're going to interpret these dependency injection as function call to the actual function. So even though there's no function call that's directly there in the code, so in this example, even though there's no direct invocation of the function ABC, we're still going to interpret this piece of code as an invocation of the function ABC with the symbol $HTTP and not HTTP. So this way, when the engine tries to identify whether A.get and B.get or actual AJAX call, it's only going to correctly identify that the first one is an AJAX call and that the second one is a false positive that it's not going to report on. So, very, very quick demo. Where's my cursor? There we go. So, we're going to first of all look at a very, very simple website that I made. And yeah, basically, we're going to look at the JavaScript file. Yep. Basically, we can see that in the code, there's like one AJAX call. Some part of it are like completely dynamic. There's some part that comes from a constant. There's one part that comes from a cookie value. So we sort of have some URL that kind of needs some analysis in order to be correctly identified. So if we look at what the endpoint tabs that the plugin adds, we can see that it both correctly identified that the prefix of the URL was like /lang, and that one part of the URL was dynamic, which is @var, and that the statement that it's coming from is $cookie line or en. So this is already some pretty good information, as we can tell that what the URL is, and we know if we're looking, for example, as to what the value can be, we're probably going to have to look in the cookie value that's named lang. Yeah, and this is the plugin for Burp. There's also the same things for Zap. I didn't make a demo, but it's basically in roughly the equivalent tab for in Zap, which is like, how is it called? Yeah, but basically, there's the exact same thing. It's about the same place for like Zap. Yep, so I'm gonna have to switch back to my slides. Yeah, so a bit of future improvement on the future improvement. Well, there's a few things that still need to get better. The engine is still primitive. It's still doing sort of okay to identify endpoints, but there's still like lots of improvement that's gonna have to be done to be an engine that can resolve, or at least can be the end goal that I have, which is to build something that's good enough to do static analysis of more complex things. And there's also, as you can see, the UI is very primitive, as I'm not a UI person. And this is something that's also going to come. So I still have, I think, a few minutes for questions. This is the GitHub of the main project. Basically, the way it's divided, there's like one GitHub project for like the engine, and there's two separate GitHub projects for the burp and the zap plugin. But both are linked from the main one, so this is the only one you need to kind of remember. Yeah. So if you have questions, there's the microphone on the back. So just raise your hand and.
Okay, we have time for about 2, maybe 3 questions. So when you ask the question, just make sure you speak into the mic. So,
thank you for the talk. Does the Endpoint Finder plugins, do they validate you find the endpoints? Couldn't the plugins just hit the endpoints to see if they actually exist?
This is not something that's currently done. But this is probably going to be in the future improvement. If you have ideas like that, you can just open an issue on GitHub too.
Were there any other questions? Going once, going twice. All right. Thank you, Olivier.
Yeah, it's good.